the vertex of a quadratic equation is not always easy to find like the previous example. So there is a formula where we can find the vertex of the graph of a quadratic equation. And in general, the x-coordinate of the vertex of the graph of ax squared plus bx plus c, remember this is the quadratic equation, is given by x equals negative b over 2a. So the vertex of a parabola can be found, the x-coordinate of the vertex, by taking negative b over 2a. And to find the y-coordinate, because remember in a point you need two coordinates, to find the y-coordinate, you just plug whatever value you get here back into your equation for x, and you get the y value of the vertex. And just remember that if a is greater than 0, the parabola opens up. If a is less than 0, the parabola opens down. So using this and the line of symmetry, we can now graph any kind of quadratic equation. We want to graph the quadratic equation y equals x squared minus 6x plus 8. So the two steps we're going to use are we're going to find the vertex and the x-intercepts and sketch the graph. And we can put in some more points to make the graph more smooth. So the x-coordinate of the vertex is given by this formula, negative b over 2a. Well, what is negative b over 2a? Negative b over 2a is going to be negative 6, which is b, over 2 times a, 2 times 1. So that will give me 3. 6 over 2 is 3. So that's the x-coordinate of the vertex. To find the y-coordinate of the vertex, we need to plug this back into my equation, like y equals 3 squared minus 6 times 3 plus 8. So that's going to give me the y-coordinate, and we calculate that out to get y equals to minus 1. So my vertex is located at, my vertex is at 3 minus 1, x and y. So we know the vertex. The next thing we do is we have to find the x-intercepts. So to find the x-intercepts, we have to set this equation equal to 0. We have to make y equal to 0 and solve for x. Thus we have to solve x squared minus 6x plus 8 equal to 0. Now to solve this equation, we can do several methods. We can use a formula, we can factor, we can use the square root property, we can complete the square. But let's try factoring, because that's the first thing you should actually attempt. If we factor this, we get x minus 4 and times x minus 2 equals 0. And so that tells me that x minus 4 is 0 and x minus 2 is 0 by the zero factor property. And so that means that x is equal to 4 and x is equal to 2. These are my x-intercepts. So we have a vertex of 3, negative 1, and we have x-intercepts at 4 and 2. So we're going to put this all together in a graph. Thus we have our vertex at 3, negative 1, the x-intercepts at 2 and 4. So I plot my vertex down here at 3, negative 1, and my x-intercept at 2, which is a 0.20, and at 4, which is a 0.40. So we have the makings of the parabola. A is positive, A is 1, so it's going to open up. And we might want to put a few points. We notice I put 1 into the equation for x, I'm going to get out 3. So we're going to have a point 1, 3 is going to be another point. And we're going to have 2, 0, 3, negative 1, 4, 0. We did these already. And then 5. Remember, this is the line of symmetry right up by the vertex. So if 1 gave me 3, 5 will give me 3 as well. So 5 is going to give me 3 here. And we can join up all the dots to form our parabola. And so this is a rough sketch of our parabola, opening upwards. Notice the x-intercepts at 2 and 4 are equidistant, as we said before, from this line of symmetry which occurs at x equals 3. Because 4 is 1 away from 3 and 2 is 1 away from 3. So they're equidistant. We can graph these equations using a graphing calculator. So let's look at how we would do this on a graphing calculator. Okay, we want to use a calculator to graph y equals x squared minus 6x plus 8. We do that by hitting y equals, which is the graphing input, the function input. And we put in y equals x squared, x is here, squared is here, minus 6x plus 8. We have to find a window in which this graph will fit. And normally I start with the standard window, which is zoom 6. And that gives me a window from negative 10 to 10 on both axes. Here's our parabola. We can also use the calculator to find the vertex, which we found before using algebra. But we can find it on the calculator by going second trace. That's second trace. And all these functions come up which we can use. Remember, we're looking for the minimum at bottom of the parabola. So we go to minimum, hit enter, and left bound, we have to be to the left of that piece, that minimum piece there. So you want to be a little bit to the left of it, hit enter. Right bound means you have to be a little bit to the right of it. So scroll to the right, hit enter, and enter again. And it comes up with your minimum at 3, negative 1. That's the vertex of the parabola, 3, negative 1, right there where the cursor is. We can also find the x-intercepts of this parabola by going second trace again. Instead of going for minimum, we're going to go for zeros, which are the x-intercepts. You hit enter, and let's say we're going to find the left one. There are 2 x-intercepts. We're going to find this one here. So we scroll to the left of that x-intercept, hit enter. It says scroll to the right of it, right bound. Scroll to the right of that x-intercept, which is slightly under here. Click enter, hit enter again. And we see my first x-intercept is at x equals 2. And you could go on and find the other x-intercept. So the graphing calculator will help you graph these parabolas.